Yannick? All right, let's see. We'll go 3, 2, 1 here. All right, so back here at CAMX 2022, I am live with Yannick. And help me again, is it Wilhelmine?
So French would say Vilma.
Vilma.
German would say Wilhelmine.
Wilhelmine. Okay.
So let's say Yannick.
Okay, we'll just say Yannick. He is he's the marketing director and manager of business development with 9T Labs. They are at booth X62, correct?
Correct.
Okay. And I don't know why the ticker is not streaming across, but that's okay. So I'm happy to have you on the show. I think we were scheduled earlier, but we had a change of schedule, but that's okay. We kind of roll with it. So tell me about 9T Labs. I mean, this is a company that's really doing some incredible work in additive manufacturing with carbon fiber. And so if you would, let's start with kind of the background of the company.
Sure.
You're based out of Zurich, Switzerland.
Yeah.
So tell us about the history of the company first.
Sure. So the company was founded 2018.
Okay.
So pretty young. It's a spin-off from ETH Zurich.
Okay.
So this is a technical university there in Zurich, pretty renowned. And what we do basically, we have a composites background. The team is now 70 people, 70. So pretty good growth in the last few years.
Yeah.
Yeah. And we are backed by great investors. So obviously they allow us to push the technology forward.
Sure.
What we do is a mix of additive manufacturing and some more known or established processes. So we do a lot of hybrid processing, mixing preforming with 3D printing, and then over molding, over injection of preforms. So this kind of stuff to really make also additive manufacturing going into serial part manufacturing.
Okay.
So not being limited to this one-off prototyping.
Okay.
Really going into structural part application. So that's the DNA of the company. We all come from aerospace, Formula One, and so on. So we want to have the strong stuff out there.
Absolutely. So what is the what's the history of the company? Founded back in
2018.
2018.
Yeah, 3 co-founders from ETH Zurich.
Awesome.
Yeah.
My favorite interviews. I love young companies like that that are doing really innovative stuff. So I'm sure you're happy to be on board, right?
Always happy to speak and share about the company, especially because we are Swiss-based.
Yeah.
But we just established an office 3 months ago in Boston.
Oh, great.
So we are also now, we have 1 foot officially in the US.
Boston's like a mecca for you guys up there, right? I mean, that's a good location.
You could say a mecca of fierce competition. But yeah, it's certainly, it's great because there is a lot of our frenemies, let's say. And
keep your what do they say? Keep your enemies close.
It's also a community. I mean, at the end, we all know each other, the founders.
Sure. Absolutely.
That's cool.
Yeah. So let's talk about some of the technology, particularly I want to talk about this Red Series fusion technology that you have. Can you explain that a little?
Sure.
Give us some background.
Sure. Yeah. We call it additive fusion technology. So basically, you have the additive from the additive manufacturing.
Right.
But maybe one step before, we start with the software. So obviously, we are substituting metal parts. That's our main target often in the applications. So we always have to go into the design phase. We have to redesign the part for composites, obviously, moving out of black metal design. And there, we would basically apply the continuous fibers where we need them, based on the load pass.
Right.
Then once we do the design, we want to verify that in the simulation. So here we are moving into commercial simulation. We have some plugins to do that very fast, to iterate between simulation and design up to the validation. Then we generate a G-code, we send it to the printer. The printer is really automated in a certain way. It always deposits the material like we want.
Okay.
And very high resolution means we put the continuous fiber where we need it. But where we don't need it, we don't want it, because that's a cost topic, isn't it?
Absolutely.
So we might have 60% fiber volume content at one point where it's critical, but 0 at another point, which is not typical for composites.
Sure, yeah.
So that's how
It's continuous throughout. So what you're doing is only applying it where the structural needs demand.
Correct. So if you take the average value of the fiber volume content, it's kind of misleading because you might have 24% of fibers in the entire volume, but 60% at the critical point.
Okay.
So that's a bit different. And then once we have the preform, we move into the fusion process, which is the last word of the additive fusion.
Yeah.
And there we really bring the properties. So that's where we remove the porosity, we get the maximum interlaminar bonding, because you always see the layers after the printing.
Sure.
And we even do some more exotic things like bringing chips, co-molding chips or organosheets with the preforms, because it's also a matter of costs, and we want to reduce costs, bring recycled materials or waste material into the game. So all this hybrid processing.
That's fantastic. So you're doing a lot of recycling. There's some sustainability going on there in your process. That's amazing. So you're kind of I guess everything in house, the software, the machines. You don't make the materials though.
Correct.
Right? You work with suppliers on that, but.
Correct. Yeah. I mean, as you say, I mean, we try, as it's a full stack solution.
Sure.
At the beginning, it's very important to understand the entire stream. But on the material side, because we go for serial part manufacturing, it's also a matter of costs and availability for specific applications, maybe specific certifications. So we very early decided we need to be open material, not to force a material to some customers. And there we have partnerships. So we have Solvay, Arkema and Evonik as collaborators or material partners. Solvay even invested in the company. But on the other side, we also say if a big OEM comes and has certified materials, we also adapt the parameters of the machine for their material, which is normally the way to go for serial part machines either way.
Sure.
But it's not common in 3D printing. 3D printing is known often as being locked.
Right.
Because that's how the business model works.
Yeah.
That's the difference now, yeah.
That's great. That's great. I meant to mention earlier, you were top 100, one of the top 100 Swiss startups. I don't know, was that 2018, 2019?
Yeah, last year we made third in the entire startup community in Switzerland. So yeah, it's great to be recognized. I guess it's super important for the team. Yeah. More than sometimes than for the business, but yeah, it gives recognition. It gives also all the people working hard inside some recognition that somehow we do good. Yeah, that's great. And it gives credibility, obviously visibility.
Primary markets you're in right now, aerospace. What are some of the primary markets you're involved in?
Yeah, I mean the top focus topics is aerospace interiors. Yeah. So those are brackets, seat structures, and so on. And the second one is what we call mobility brackets. Can be suspension, rocker arms, anything where you want to have high structural performance and lightweight together.
Sure. Right. I was noticing some of the markets, even luxury watches, right? I mean, that's pretty kind of
This I would say is a Swiss topic, isn't it? So
of course.
Being a Swiss company, I mean, it's not as such a target market. It's a nice opportunity for us. Yeah. Because, of course, it's visibility. It's also branding because it's Swiss, and for us. It's a good way. I mean, now in November, there will be the first watch. It's a limited series of 1,000. Sure. Where we have printed the watch case. I mean, we're not printing the entire watch, obviously. Right. But the watch case is now made with our technology. Okay. There will be a second watch next year. Sure. And yeah, that's great because it's visible. We can do branding with that. Yeah. And it helps also showing that, yes, we can do 1,000 parts at this level of quality. And then we can apply that to aerospace, knowing, of course, there is certification behind.
I'm curious, I guess the additive manufacturing from a standpoint of cycle time and production time, what does that look like with the printers that you run from start to finish in terms of production?
Sure. Yeah, I mean, actually, additive manufacturing and 3D printing is not fast. Yeah. I mean, let's be honest. So that's why we really say what is interesting in this 3D printing process is the automation level
Yeah.
and the level of accuracy where to put, which are co-molded
Okay.
in a super fast way. So we really try to maximize the efficiency of different processes, taking the best of different worlds, while of course considering the end performance
Sure.
and the costs.
How has I love the fact that, you know, from a standpoint of in your process adding the structural fiber to the areas only needed, I'm sure has reduced a lot of your costs, right?
Yeah, definitely. I mean, at the end on the parts, between 40 and 60%, the final costs are impacted from the material. So whenever we can remove continuous fiber, because those are the expensive
Right.
parts, then it's a gain on the total cost of the part.
Sure.
So that's where the design software is a really big help, because that's where we can play very fast. And then of course how to mix these processes, so additive with
Sure.
the others.
Sure.
That's how to make it happen.
This has been fascinating. I'm glad you stopped by. I've
Sure.
enjoyed talking. Where can people find our listeners and, first of all, attendees? It's supposed to be streaming, but it isn't. I want to mention your booth again. That's X62.
Correct.
And the website is 90labs.com, correct?
Correct, yeah.
Okay.
And you can find us on LinkedIn and so on. So
Okay. Fantastic. Yannick, thank you so much for stopping by. Enjoyed it.
thank you, John.
Yeah, enjoy the show, and best of success to you all at this show and beyond. Look forward to talking to you again in the future.
Thank you.
Good.
Talk to you soon.
See, that was painless. Oh.
You didn't stream?
No, well, it was streaming, but it's the ticker was supposed to.
Okay.
Here, so this was supposed to be going down. That's okay. We mentioned it.